Welcome to GCP Firewall Policies. Welcome everyone. Today we are diving deep into Google Cloud Platform's firewall policies, one of the most transformative security features available in GCP. This isn't just another incremental improvement. It is a complete paradigm shift in how we approach cloud network security. Let me paint you a picture of the traditional approach. Imagine you are running security for a large corporation with 50 office buildings scattered across different cities. In the old model, each building has its own security team with their own rulebook. Building A might allow visitors between 9 and 5, Building B might require escort badges, and Building C might have completely different policies. This creates inconsistency, gaps in security, and a management nightmare. Firewall policies are like establishing a centralized corporate security department. You create unified policies that can be applied consistently across your entire organization, while still allowing for local customization where needed. It is the difference between having 50 separate security teams versus having one intelligent, coordinated security organization. The key benefits we will explore today include centralized management, intelligent threat detection, advanced filtering capabilities, and enterprise-scale governance. We will cover everything from basic concepts to advanced enterprise features, with real commands and practical examples you can implement immediately in your own environment. By the end of this session, you will understand not just how to use firewall policies, but why they represent the future of cloud network security and how they can transform your organization's security posture. The evolution of network security. To truly appreciate the power of firewall policies, we need to understand the evolution of network security. In the early days of computing, networks were simple and mostly trusted. We had basic packet filters that essentially asked, "What's your source IP? What's your destination? Are you using an allowed port?" If you passed those basic checks, you were in. Then came stateful firewalls that could track connection states and understand the context of communications. This was a major improvement, but we were still fundamentally limited to Layer 3 and Layer 4 inspection. We could see who was talking and where they were going, but we had no idea what they were saying or why they were having that conversation. Google Cloud's VPC firewall rules, while powerful and reliable, are still fundamentally built on this traditional model. They're like having a very efficient bouncer at a club who checks IDs and maintains a guest list, but can't actually tell if someone is carrying something dangerous in their briefcase. Cloud NGFW represents a quantum leap forward. It's like upgrading from that bouncer to a sophisticated airport security checkpoint with X-ray machines, background check databases, and behavioral analysis. Instead of just asking who are you and where are you going, we can now ask what are you carrying? Are you on any watch lists? What's your intended destination by name, not just IP address? And does your behavior match known attack patterns? This evolution from reactive to proactive, from static to intelligent, from simple to contextual, that's what makes this truly next-generation technology. Core Architecture Deep Dive. Let's dive deep into the architectural foundation that makes firewall policies so powerful. The traditional VPC firewall model is like having individual security guards at each building entrance, each with their own clipboard and their own interpretation of the rules. It works, but it's inefficient and prone to inconsistency. Firewall policies introduce a hierarchical, inheritance-based model that's similar to how modern corporations handle governance. At the top level, you have organization-wide policies. These are like federal laws that apply to everyone, no exceptions. Think, all employees must wear security badges, or no one is allowed in the server room without escort. Below that, you have project-level policies that can be either global, applying to all regions within a project, or regional, specific to a particular geographic region. These are like departmental policies. The engineering team might have different access requirements than the marketing team, and the EU office might have different compliance requirements than the US office. The magic happens in how these policies interact through inheritance and evaluation order. When a packet arrives at your network, it doesn't just hit one policy. It goes through a carefully orchestrated evaluation process that checks organizational mandates first, then departmental policies, then local rules. This hierarchy gives you three critical capabilities. Consistency, meaning everyone follows the same core rules. Flexibility, where departments can customize as needed. And scale, enabling you to manage thousands of resources with dozens of policies instead of thousands of individual rules. The evaluation order is crucial and follows a strict hierarchy. Hierarchical policies, followed by global policies, then regional policies, and finally, traditional VPC rules. This ensures that organizational mandates always take precedence, while still allowing for appropriate customization at lower levels. Understanding policy types in detail. Now, let's explore the three types of firewall policies in detail, because understanding when and how to use each type is crucial for building an effective security architecture. Hierarchical policies are your organizational mandates, the non-negotiable, company-wide security rules that apply to every single resource in your organization. These are created at the organization or folder level in your Google Cloud resource hierarchy. Think of these as federal laws that supersede all local regulations. For example, they can include blocking all traffic from sanctioned countries, preventing access to known malicious IP addresses, or enforcing encryption requirements. The key thing about hierarchical policies is that they require organization-level 1AM permissions to create and manage. This isn't something every developer can modify. It's typically managed by your central security team. When a packet matches a hierarchical policy rule, that decision is final. No lower-level policy can override it. Global network policies operate at the project level but span all regions within that project. These are perfect for application-specific rules that need to apply everywhere your application runs. For example, if you have a microservices architecture deployed across multiple regions, you might have a global policy that allows your API gateway to communicate with your backend services, regardless of which region they're in. Regional network policies are the most granular and are specific to both a project and a region. These are ideal for region-specific compliance requirements, like GDPR in Europe requiring certain data handling practices, performance optimizations like allowing faster intra-region communication, or cost optimizations like keeping certain traffic within a region to avoid egress charges. The beautiful thing about this architecture is that you can layer these policies. A single VPC network might be subject to hierarchical policies, like organization-wide security, global policies, like application-specific rules, and regional policies, like location-specific requirements, all at the same time, with the evaluation order ensuring everything works together harmoniously. The policy hierarchy in action. This is where the rubber meets the road. Understanding exactly how packet evaluation works in the hierarchical model is crucial for designing effective security architectures and for troubleshooting when things don't work as expected. When a packet arrives at your network, it doesn't just randomly check rules. There's a very specific, deterministic evaluation process that follows the organizational hierarchy. Think of it like the chain of command in a military organization. Decisions flow from the top down, and lower levels can only act when higher levels haven't already made a decision. First, the packet is evaluated against any hierarchical policies. These are your organizational mandates, the rules that your security team has decided are non-negotiable for the entire company. If a hierarchical policy matches the packet, that's it. The decision is made, and the evaluation stops. This could be an A-LLOW, for example, permitting access to critical corporate services, or ADENY, for example, blocking traffic from known malicious countries. If no hierarchical policy matches, or if a hierarchical policy uses the special go-to next action, the evaluation continues to the global network policies. These are your application-level rules that span multiple regions. Again, if a global policy matches and makes a decision, evaluation stops. Next comes regional policies, which handle region-specific requirements. Finally, if no policy at any level has made a decision, the packet is evaluated against traditional VPC firewall rules. The go-to next action is particularly powerful because it allows you to create policies that observe and log traffic without making the final decision. For example, you might have a hierarchical policy that logs all access attempts to sensitive resources but uses the go-to next action to allow lower-level policies to make the actual allow/deny decision. This evaluation order gives you precise control. Organizational security can't be bypassed, but individual teams still have the flexibility they need to operate effectively. Traditional versus next general comparison deep dive. Let me show you exactly what makes this next generation by comparing the capabilities side by side, because the differences are profound and game-changing. Traditional VPC firewall rules operate at Layer 3 network and Layer 4 transport. They can see IP addresses, ports, and protocols, but they are essentially blind to what is actually happening inside the communication. It is like having a security guard who can check your ID and see which building you are going to, but has no idea what you are carrying in your briefcase or what you plan to do once you get there. Next-gen firewall policies can operate at Layer 7 application layer with Cloud NGFW Enterprise. This means they can understand and make decisions based on the actual content and context of communications. They can see that you are trying to access github.com rather than just connecting to IP address 140.82.114.4. And they can understand the difference between legitimate HTTPS traffic and an encrypted command and control channel. FQDN, fully qualified domain name filtering, is revolutionary because it solves the dynamic IP problem. In the traditional model, if you wanted to allow access to GitHub, you would have to maintain a list of GitHub's IP addresses, and GitHub has hundreds of IP addresses that change constantly. With FQDN filtering, you simply specify github.com or star.github.com and the firewall handles the dynamic IP resolution in real time. Geolocation filtering lets you make decisions based on where traffic is coming from geographically, not just which IP addresses. You can block entire countries, allow only specific regions, or create rules that automatically adapt to threats emerging from particular geographic areas. Threat intelligence integration means your firewall is constantly updated with the latest threat data from Google's security team. When a new botnet is discovered or a new command and control server comes online, your firewall knows about it within minutes, not days or weeks. The management scope difference is equally important. Instead of managing hundreds of individual rules scattered across dozens of VPCs, you create centralized policies that cascade down through your organization. This is not just more convenient, it is fundamentally more secure because it reduces the chance of configuration errors and security gaps. Creating your first policy command deep dive. Now let's get hands-on and create our first firewall policy. I'll walk through each command in detail, explaining every parameter and what it does. Understanding these commands thoroughly is crucial for effective policy management. When creating a regional firewall policy, the G Cloud Compute Firewall Policies Create command is your starting point. The first parameter, My Web App Policy, is the name of your policy. Choose this carefully, because it will be referenced throughout your infrastructure and should clearly indicate the policy's purpose and scope. The project parameter specifies which GCP project will own this policy. This is important for billing, access control, and resource organization. The policy will be created within this project's context and can only be associated with VPCs in the same project. The region parameter defines where this policy can be used. Regional policies are tied to specific geographic regions like ES Central 1 or Europe West 1. This affects both where the policy's resources are stored and which VPCs it can be associated with. You can only associate a regional policy with VPCs in the same region. The description parameter is more than just documentation. It's crucial for maintaining clarity in complex environments. In 6 months, when you're troubleshooting a connectivity issue, a clear description will save you significant time in understanding what this policy was intended to do. The display name provides a human-readable name that appears in the Google Cloud Console. While the policy name must follow naming conventions, The display name can be more descriptive and user-friendly. For global policies, you replace region with global, and the policy can be associated with VPCs in any region within the project. For hierarchical policies, you use organization or folder instead of project, and these policies can apply to resources across multiple projects within the organizational hierarchy. The command returns a confirmation that includes the full resource name of the created policy, which you'll use in subsequent operations like adding rules or creating associations. Policy management commands explained. Effective policy management requires mastering the full suite of management commands. Let me walk through each one in detail, because in production environments, you'll spend as much time managing existing policies as creating new ones. The list command with various parameters is your primary tool for discovering and inventorying policies. When you specify regions equals US Central 1 Europe West 1, you're telling G-Cloud to search for regional policies in those specific regions only. This is crucial in large environments where you might have dozens of regions and hundreds of policies. The global flag lists only global policies within the specified project. These are policies that can be associated with VPCs in any region within that project. The organization flag lists hierarchical policies, but remember that this requires organization-level permissions. The filter parameter is incredibly powerful for finding specific policies in large environments. The syntax name /webapp* uses pattern matching to find all policies whose names start with webapp. You can also filter by other attributes like creation time, description, content, or association status. The describe command gives you the complete details of a policy, including all its rules, associations, and metadata. The format equals YAML parameter presents the output in YAML format, which is often more readable than the default format, especially for complex policies with many rules. The describe command shows you critical information like which VPCs the policy is associated with, what rules it contains, when it was created and last modified, and who has permissions to modify it. This information is essential for troubleshooting and security auditing. Understanding these management commands is crucial because in production environments, you'll regularly need to audit your security posture, troubleshoot connectivity issues, and ensure compliance with organizational policies. The ability to quickly find and inspect the right policies can mean the difference between a 5-minute fix and a 5-hour investigation. Adding intelligent rules. Command breakdown. Now we get to the really exciting part. Adding intelligent rules that leverage next-generation capabilities. Let me break down each command in detail because these represent a fundamental shift from traditional firewall rule creation. The Threat Intelligence rule demonstrates real-time integration with Google's security feeds. The command G-Cloud Compute Firewall Policies rules create 100 starts with priority 100. Remember that lower numbers have higher priority, so this rule will be evaluated early in the process. The source threat intelligences equals IP list known malicious IPs parameter is where the magic happens. Instead of maintaining your own list of bad IP addresses, you're connecting directly to Google's managed threat intelligence feeds. These feeds are continuously updated as Google's security teams discover new threats, compromised hosts, and malicious infrastructure. The enable logging parameter is crucial for security monitoring and compliance. When this rule triggers, it will create detailed log entries that you can analyze with Google Cloud Logging, export to your SIEM, or use for automated response systems. The FQDN filtering rule showcases another next-gen capability. The destination FQDNs equals github.com, star.google.com, star.googleapi.com parameter allows you to specify destinations by domain name rather than IP address. The asterisk is a wildcard that matches any subdomain, so star.google.com would match mail.google.com, drive.google.com, etc. The layer 4 configs equals TCP:443. TCP:80 parameter specifies that this rule applies to HTTPS and HTTP traffic. This replaces the old allow parameter from VPC rules and provides more flexibility for complex protocol configurations. The target service accounts parameter demonstrates identity-based security. Instead of applying the rule to all resources, you are specifically targeting resources that run with a particular service account identity. This provides much more granular and secure targeting than network tags. The geolocation rule shows how you can make decisions based on geographic origin. The source region codes equals CN, RU, KP parameter blocks traffic from China, Russia, and North Korea using standard ISO country codes. This kind of geographic blocking would be impossible with traditional IP-based rules because you would need to maintain constantly changing lists of IP address ranges for each country. Policy association. Making policies active. Creating a policy is just the first step. Until you associate it with a network, it is just sitting there doing nothing. Policy association is where your security rules become active and start protecting your infrastructure. So understanding this process in detail is critical. The association command G Cloud Compute Firewall Policies Associations creates a binding between a policy and a VPC network. The firewall policy parameter specifies which policy you are activating, and the firewall policy region parameter tells the system this is a regional policy in the US Central 1 region. The network parameter requires the full resource path of the VPC network. Project/my GCP project/global/networks/webapp VPC. This ensures there is no ambiguity about which network you are targeting, which is crucial when you have multiple projects and networks. The name parameter creates a named association resource. This name is important because it is how you will reference this association later if you need to modify or delete it. Choose names that clearly indicate both the policy and the network involved. Behind the scenes, when you create this association, Google Cloud is spinning up firewall endpoints within your VPC network. These endpoints transparently intercept and evaluate all traffic according to your policy rules. The association process typically takes a few minutes to complete as these endpoints are provisioned and configured. The list command for associations shows you all the active bindings for a policy. This is crucial for understanding which networks are protected by which policies, especially in complex environments where policies might be associated with multiple networks or where networks might have multiple policy types applied. The delete command removes the association, which effectively deactivates the policy for that network. This does not delete the policy itself, just the binding. However, be very careful with this command in production environments because removing a policy association can immediately change your security posture and potentially disrupt traffic flow. Understanding policy association is crucial because this is where theoretical security policies become practical network protection. It is also where misconfigurations are most likely to cause outages, so always test in non-production environments first and have a rollback plan ready. Advanced Rule Configuration Deep Dive. Now let's explore the more sophisticated rule configurations that really showcase the power of firewall policies. These advanced rules go beyond basic allow, deny decisions and provide the kind of granular control that enterprise security teams need. Secure tags represent a revolutionary approach to resource identification. Unlike network tags, which are just simple strings that anyone with virtual machine access can modify, secure tags are full IAM resources with strict access controls. Think of the difference between a handwritten name tag and a government-issued ID card with biometric verification. When you create a rule using secure tags, you're leveraging Google Cloud's Resource Manager to provide cryptographically verifiable resource identification. The tag keys are defined at the organization level by security administrators, and the ability to apply specific tag values is controlled through IAM permissions. This means a developer can't just decide their virtual machine is production. They need explicit permission to apply the environment equals production tag. Address groups solve the problem of managing large lists of IP addresses or CIDR ranges. Instead of embedding IP lists directly in firewall rules, You create named address groups that can be updated independently. This is crucial for maintaining rules that reference hundreds of IP addresses, like partner networks or trusted third-party services. The go-to next action is particularly powerful for implementing layered security and gradual migrations. When a rule uses go-to next, it means I've looked at this traffic and logged it, but I'm not making the final decision. Pass it down to the next policy level. This allows you to create observability rules at higher levels while leaving the actual enforcement to more specific rules at lower levels. Address groups and FQDN objects management. Address groups and FQDN objects are fundamental building blocks for scalable firewall management. Let me explain why these are so important and how to use them effectively in production environments. Traditional firewall rules often embed IP addresses directly in the route configuration. This creates a maintenance nightmare when those addresses change. Imagine having 50 firewall routes that all reference your partner company's IP addresses, and then they notify you that they're changing their network infrastructure. You'd have to update 50 individual routes, with the risk of missing one and creating a security gap. Address groups solve this by creating a level of indirection. You create a named group like partner company IPs and populate it with their current addresses. Your firewall routes reference the group name, not the individual IPs. When the partner's addresses change, you update just the address group, and all routes referencing it automatically use the new addresses. FQDN objects work similarly but for domain names. Instead of trying to track the constantly changing IP addresses for services like GitHub or Google APIs, you create FQDN objects that contain domain names with wildcard support. The firewall automatically resolves these domain names to current IP addresses in real time. The power of both address groups and FQDN objects is that they can be shared across multiple policies and routes. You might have separate policies for production and staging environments, but both can reference the same approved external API's FQDN object. This ensures consistency while reducing management overhead. When you update an address group or FQDN object, the changes propagate to all routes that reference them within minutes. Security profile. Cloud address groups and FQDN objects management. Address groups and FQDN objects are fundamental building blocks for scalable firewall management. Let me explain why these are so important and how to use them effectively in production environments. Traditional firewall rules often embed IP addresses directly in the route configuration. This creates a maintenance nightmare when those addresses change. Imagine having 50 firewall routes that all reference your partner company's IP addresses, and then they notify you that they're changing their network infrastructure. You'd have to update 50 individual routes, with the risk of missing one and creating a security gap. Address groups solve this by creating a level of indirection. You create a named group like partner company IPs and populate it with their current addresses. Your firewall routes reference the group name, not the individual IPs. When the partner's addresses change, you update just the address group, and all routes referencing it automatically use the new addresses. FQDN objects work similarly but for domain names. Instead of trying to track the constantly changing IP addresses for services like GitHub or Google APIs, you create FQDN objects that contain domain names with wildcard support. The firewall automatically resolves these domain names to current IP addresses in real time. The power of both address groups and FQDN objects is that they can be shared across multiple policies and routes. You might have separate policies for production and staging environments, but both can reference the same approved external API's FQDN object. This ensures consistency while reducing management overhead. When you update an address group or FQDN object, the changes propagate to all routes that reference them within minutes. This provides a centralized way to manage network access without having to touch individual firewall routes. Cloud NGFW Enterprise, the full security suite. Cloud NGFW Enterprise represents the pinnacle of Google Cloud's firewall capabilities, providing advanced security features that were previously only available in dedicated security appliances. This isn't just an incremental upgrade. It's a completely different class of security platform. The key difference is the introduction of firewall endpoints. Think of these as intelligent security checkpoints that are transparently inserted into your network fabric. Unlike traditional firewalls that require you to route traffic through specific devices, firewall endpoints operate at the network fabric level, inspecting all traffic without changing your network topology. Layer 7 inspection is where enterprise really shines. Traditional firewalls can see that you're making an HTTP/HTTPS connection to a specific IP address, but they can't see what's inside that encrypted connection. Enterprise-level inspection can decrypt, analyze, and re-encrypt traffic in real time, allowing it to detect threats hidden inside encrypted communications. The Intrusion Prevention Service, IPS functionality, continuously analyzes traffic patterns against Google's threat intelligence database. This isn't just signature-based detection. It includes behavioral analysis that can detect zero-day attacks and advanced persistent threats that don't match known signatures. Security profile groups allow you to package multiple security policies together and apply them as a unit. You might have one profile group for production workloads that includes strict intrusion prevention, TLS inspection, and comprehensive logging, and another profile group for development environments with more relaxed policies. The enterprise features require careful planning because they involve additional infrastructure components and have performance implications. However, for organizations with serious security requirements, these capabilities provide enterprise-grade protection that's fully managed by Google Cloud. Security profiles and profile groups deep dive. Security profiles are where Cloud NGFW Enterprise really demonstrates its sophistication. These are not just simple allow or deny rules. They are comprehensive security policies that define how the system should respond to different types of threats and traffic patterns. Threat prevention profiles contain thousands of signatures for known attacks, malware, and suspicious behaviors. But unlike traditional signature-based systems, these profiles are continuously updated by Google's security team based on global threat intelligence. When a new attack is discovered anywhere in Google's global infrastructure, that intelligence is rapidly distributed to all Cloud NGFW enterprise deployments. The beauty of the profile system is the flexibility in response actions. Instead of just blocking or allowing traffic, you can configure nuanced responses, like alert but allow, reset connection, drop packet silently, or redirect to quarantine. This allows you to implement sophisticated security policies that balance protection with operational requirements. Security profile groups bundle multiple profiles together for easy management. Think of this like creating standardized security templates for different types of workloads. For example, your high-security production profile group might include strict threat prevention, comprehensive logging, and TLS inspection. While your development environment profile group might have more permissive policies that prioritize functionality over security. The organization-level scope of security profiles is crucial for enterprise governance. Security teams can define approved security profiles at the organization level, and individual teams can only use those pre-approved profiles. This ensures consistency across the organization, while preventing teams from accidentally or intentionally weakening security postures. Profile inheritance and management becomes critical in large organizations. You might have baseline security profiles that apply to all workloads, with additional specialized profiles for specific types of applications or compliance requirements. Rule management and updates in production. Managing firewall rules in production environments requires a systematic approach that balances security, reliability, and agility. Let me walk you through the best practices for rule lifecycle management that will help you avoid outages and security gaps. The update command is your primary tool for modifying existing rules, but it is important to understand what can and cannot be changed safely in production. You can modify priorities, descriptions, and certain match criteria without disrupting traffic, but changing fundamental aspects like direction or action types requires more careful planning. Priority changes are particularly important to understand. When you change a rule's priority, you're potentially changing the order in which rules are evaluated, which could have unexpected consequences. Lower priority rules that were previously unreachable might suddenly become active, or high priority rules might start catching traffic that was previously handled by other rules. The enable and disable operations provide a safe way to temporarily deactivate rules without deleting them. This is incredibly useful for troubleshooting. You can disable a suspect rule to see if it resolves connectivity issues, then re-enable it once you have identified the actual problem. Always disable rather than delete when troubleshooting, because recreation is more error-prone than re-enabling. Rule descriptions might seem like just documentation, but in complex environments, they become crucial for operational efficiency. A good description includes the business justification, the expected traffic patterns, and any special considerations for maintenance or updates. When you are troubleshooting at 2 a.m., these descriptions can save hours of investigation time. Bulk operations require extra caution because they can affect multiple rules simultaneously. Always use the dry run flag when available, and consider making changes in small batches rather than updating everything at once. This reduces the blast radius if something goes wrong and makes it easier to identify which change caused a problem. Advanced monitoring and logging deep dive. Monitoring and logging are where firewall policies really show their value in production environments. This is not just about compliance. Good logging and monitoring are essential for security operations, troubleshooting, and capacity planning. Firewall logs contain incredibly rich information, but you need to understand the structure to extract maximum value. Each log entry includes not just the basic connection information, source, destination, port, but also which rule matched, which policy the rule belongs to, and detailed metadata about the decision-making process. The resource.type equals GCE_subnetwork filter in cloud logging is your starting point for finding firewall logs, but you will quickly need more sophisticated queries for operational use. Learning to filter by rule names, policy names, and specific network patterns is essential for efficient troubleshooting. Log aggregation and analysis become critical at scale. You might generate millions of firewall log entries per day, so you need strategies for extracting actionable insights. This might include creating custom dashboards, setting up automated alerting for suspicious patterns, or exporting logs to specialized security analysis tools. Effective firewall monitoring provides insights into both security and operational issues. You can identify attack patterns, discover unauthorized access attempts, and also find legitimate traffic that is being blocked by overly restrictive rules. This dual perspective, security and operations, is crucial for maintaining both protection and functionality. Log retention and storage costs can become significant at scale, so you need strategies for balancing visibility with cost. This might include sampling high-volume legitimate traffic while retaining full logs for denied connections, or using different retention periods for different types of log entries. Real-time monitoring capabilities allow you to detect and respond to security incidents as they happen, rather than discovering them hours or days later during routine log analysis. Setting up proper alerting for firewall events is an essential part of a comprehensive security monitoring strategy. Troubleshooting firewall-related connectivity issues is a critical skill for anyone managing cloud infrastructure. Firewall policies add complexity to troubleshooting because of the hierarchical evaluation model, but they also provide more detailed visibility into why connections are failing. The hierarchical testing approach is essential because a single connection might be evaluated by multiple policy types. You need to systematically check hierarchical policies first, then global policies, then regional policies, and finally VPC rules. A connection might be allowed at the regional level but blocked by a hierarchical policy, and understanding this evaluation order is crucial for effective troubleshooting. The Get Effective Firewalls command is incredibly powerful for understanding what rules actually apply to a specific instance. This command shows you all the firewall rules that affect a particular virtual machine, taking into account the complex inheritance and evaluation order. This is often the fastest way to understand why a connection is or isn't working. Log analysis for troubleshooting requires understanding the difference between no log entry and explicit deny log entry. If you don't see any log entries for a connection attempt, it might mean the traffic never reached the firewall, routing issue, network configuration problem, or that logging isn't enabled for the relevant rules. An explicit deny log entry tells you exactly which rule blocked the traffic and why. Common connectivity issues often involve misunderstanding the evaluation order, incorrect target specifications, wrong service accounts or tags, or conflicts between different policy types. Learning to quickly identify these patterns will make you much more effective at troubleshooting. Testing tools and techniques include using targeted test connections, enabling temporary logging on specific rules, and using packet capture tools when available. The key is to use systematic approaches rather than randomly trying different configurations. Performance optimization and best practices. Performance optimization for firewall policies involves understanding how the evaluation engine works and designing your route structure to minimize processing overhead while maintaining security effectiveness. Route prioritization strategy is crucial for performance. The evaluation engine processes routes in priority order, lowest number first, and stops at the first match. This means you should place your most specific, frequently matched routes at higher priorities, lower numbers, and your broad, catch-all routes at lower priorities, higher numbers. The number of routes in a policy affects evaluation performance, but not linearly. Google's evaluation engine is highly optimized, but policies with thousands of routes can still impact performance, especially if they include complex matching criteria like FQDN resolution or threat intelligence lookups. Target specification efficiency matters significantly. Using service accounts for targeting is generally more efficient than using network tags because service accounts are immutable attributes of virtual machines, while tags can change. Secure tags provide the best balance of security and performance because they are IAM controlled but efficiently indexed for firewall evaluation. FQDN resolution caching helps with performance, but you need to understand that there is a trade-off between accuracy and speed. The system caches DNS resolutions for efficiency, but this means that very rapid IP address changes might not be immediately reflected in firewall decisions. Policy association optimization involves understanding that each VPC network can have multiple policy associations, and the complexity of your policy hierarchy affects evaluation performance. Simpler hierarchies with fewer policy levels generally perform better than complex multi-layered structures. Monitoring performance metrics helps you understand the impact of your firewall configuration on network performance. Key metrics include route evaluation latency, policy compilation time, and association update propagation time. Migration strategies and best practices. Migrating from traditional VPC firewall rules to firewall policies is a complex undertaking that requires careful planning and a systematic approach. This isn't just a technical migration. It's often an organizational change that affects how teams manage network security. The assessment phase is critical for understanding your current security posture. You need to inventory all existing VPC firewall rules, understand their dependencies, and map them to business functions. This assessment often reveals inconsistencies and gaps in existing security policies that should be addressed during the migration. Parallel deployment using the go-to_next action is the safest migration approach. You deploy new firewall policies alongside existing VPC rules, initially using go-to_next actions to observe traffic without making enforcement decisions. This allows you to validate that your new policies correctly handle all legitimate traffic before switching to enforcement mode. Gradual cutover involves slowly moving from observation to enforcement, typically starting with non-critical systems and gradually expanding to production workloads. The ability to quickly roll back is essential during this phase, So maintaining both the old VPC rules and new policies until the migration is fully validated is crucial. Testing strategies need to be comprehensive because firewall changes can have subtle effects that only appear under specific conditions. This includes testing normal traffic flows, error conditions, failover scenarios, and edge cases that might not be obvious during initial validation. Organizational change management is often overlooked but critical for success. Teams need training on the new policy model, updated runbooks for troubleshooting, and clear ownership models for who can create and modify policies at different organizational levels. Documentation and knowledge transfer ensure that the migration benefits persist beyond the initial implementation. This includes updated network diagrams, security architecture documentation, and training materials for ongoing operations teams. Security governance and compliance. Firewall policies offer powerful capabilities for implementing enterprise security governance and meeting compliance requirements. Effectively leveraging these capabilities is crucial for organizations with sophisticated security and compliance needs. Hierarchical policy enforcement enables central security teams to implement non-negotiable security controls, while still providing individual teams the flexibility they need to operate effectively. This is the key to scaling security governance. You can enforce broad organizational policies while allowing for appropriate local customization. IAM integration with firewall policies provides fine-grained access control over who can create, modify, and delete security policies. This is essential for maintaining security boundaries and ensuring that security decisions are made by appropriate personnel with proper authorization. Audit trails and compliance reporting are built into the firewall policy system through integration with cloud logging and cloud audit logs. Every policy change, rule modification, and association update is logged with full context about who made the change, when, and from where. Compliance frameworks like SOC 2, PCI DSS, and HEPA often have specific requirements for network security controls and audit trails. Firewall policies provide the granular control and comprehensive logging needed to meet these requirements while maintaining operational efficiency. Security posture validation involves regularly reviewing and auditing your firewall policies. This ensures they continue to meet your security requirements as your infrastructure evolves. This includes identifying unused rules, detecting overly permissive policies, and ensuring that security controls remain effective as applications and traffic patterns change. Incident response capabilities are enhanced by the detailed logging and policy structure provided by firewall policies. When security incidents occur, you can quickly understand which policies were involved, what traffic was allowed or denied, and implement rapid containment measures through policy updates that propagate across your entire infrastructure within minutes. The combination of centralized control, detailed logging, and flexible enforcement makes firewall policies an essential tool for organizations that need to balance security, compliance, and operational agility in large-scale cloud environments.